Okay, video 2 here. All right. So next, is the domain for each situation continuous or discrete? So we're going to talk about two different words here. The words are continuous, and the words are discrete. Continuous and discrete. Okay. So when we talk about the word continuous, right? So think about when you see continuous. So when you see the word continuous, that means the graph is connected. Continuous means connected. So if you look at this first graph, you see how this is just a line. It's not a bunch of dots. That means this is continuous. Okay? A discrete graph is going to be dots or points, right? But D for dots. So notice here in the second one, you see a bunch of points. This is a discrete graph. So again, when you are continuous, okay, your graph is a line or a curve. When you are discrete, right, it's going to consist of a series of data points. Now, what I want to do here is I want to talk about what the domain and range would be for each of these graphs, because part of this class is identifying what the domain and range would be. So first off, right, I want to kind of edit this graph real fast. I do want to put a solid dot here, so ignore that arrow there. So solid dot there, and then yes, this line goes up and to the right, and let's pay attention to that arrow. Okay, so your domain are your x's. So this is a continuous graph, so C-O-N-T. This is a continuous graph. It's a connected, it's a ray, but a line. It starts at the point 0, 0. The first 0 is the x, the second 0 is the y. This arrow is going up and to the right. So for the domain, we are starting at 0 on our x, and we're going to the right. So that means that our domain, our x values, must be greater than or equal to 0. Again, in this problem, and again, I've kind of ignored that. Let me try to move this. Okay, in this problem, the x is your time. So again, time is what we call a continuous variable, because you can have, what are these in minutes? So you could have 1 minute, you could have 2 minutes, but you could also have 1 minute and 30 seconds. You could have 1 minute and 45 seconds. So again, you can have smaller increments of time. That's why it's continuous. Okay? The range in this case is the y values. Again, we're starting with the y value of 0, and again, we're also going up. And again, because of that arrow, we're going up without bound. So we say y is going to be greater than or equal to 0 as well. And again, volume is a measurement. It is continuous. Yes, 0 gallons, 8 gallons, but you could have 6.3 gallons. You could have 8.2 gallons, right? You could have smaller increments of gallons. Okay? So for continuous, typically use inequalities as your domain and range. Okay, now over here we have a bunch of dots. Now again, I'm going to add a dot right here at 0, 0. I don't know why they always ignore that, but I'm going to put that there. So this is a discrete graph. D-I-S-C, discrete graph. Therefore, when I list the domain and range, we're just going to list data points. Okay, so to do that, I have to kind of understand what my data points are. Now, notice on the red domain and range, I didn't put the braces. Here I will put the braces because I'm listing numbers. Okay, so this point is 0, 0. So again, the x and the y. This point right there, notice that my x's are counting by 1s, but my y's are counting by 4s. Again, this is tables and chairs. What this means is, because that point is 1, 4, that means that every table has 4 chairs, right? And that's what it says right here. One table has 4 chairs. So your tables are growing by 1. So your domain, which is the tables, is 0, 1, 2, dot, dot, dot. And again, we're going to keep going without end. These are called the whole numbers. Whole numbers. Whole numbers. Again, sorry that my writing's kind of small sometimes. Whole, I'll write it bigger. I just don't take my time and write down each letter. Whole, there we go, numbers. Whole numbers are the counting numbers starting with 0. So 0, 1, 2, 3. Now your range is not going to be 0, 1, 2, 3. Your range is going to go by 4s. So 0, and then if you have one table, you have 4 chairs. If you have 2 tables, you have 8 chairs, and so on. So in this case, our range is the domain value times 4. So those numbers are 4 times the x. There we go. But this is discrete. So continuous versus discrete. So when we look at these graphs, right, and try to identify the domain and range, again, continuous inequalities, discrete dots, numbers. All right, perfect. All right. Okay, so is the relation a function? All right, so again, I want to list out the domain and range and then talk about whether it's a function or not, okay? Just because I want to emphasize domain and range. So the x's, x, 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 x. So my domain, and in order, are 1, 5, 7, and 8. My range are my y's, y, 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 y. If I try to go in numerical order, it'd be -1, 0, 2, 6. Not necessary, but what I'm going to do. Now, for this problem here, right, the easiest way to determine whether a list of ordered pairs is a function or not is ask yourself, do any x values repeat? Right? Do any x values repeat? And it's the x's, not the y's. And if I look at here, I would say no, right? 1, 5, 7, 8. All of the x's are new. So this is going to be a function because each x is going to belong to exactly one y. Okay. Next. All right, so now we have a mapping. So it says, is the relation a function? So again, I'll change the blue, change it up a little bit. So let's go with the domain. So the domain are the x values. That's the numbers with the arrows coming from them. So these are the x values, these are the y values. So in order, 1, 2, 3, 4, 5. For the range, in numerical order, 10, 11, 17. So now again, is this a function? Does each x go only to one y? Well, if you look, this has one arrow, this has one arrow, this has one arrow, this has one arrow, this has one arrow. Yes, this is a function because each x only goes to one y. Now, don't let them confuse you with this top part. 1 and 2 both going to 17 is okay. It is not like this, where 1 is going to, say, 17 and 11. This is bad. That means not a function. But if two x's have the same y, that is okay. It can still be a function. Okay. Last but not least here. Okay, so now we're going to talk about the vertical line test. So it says state the domain and range of each continuous graph. So notice right here, we're looking at continuous graphs. And again, we want to know what the domain and range are, and then again, use the vertical line test to determine if it's a function. So if I take a look at this first graph, so my starting point is right here. I'm going to use blue to go different. So this is my starting point at 0, 0. Notice that this arrow is going up and to the right. So for my domain, I am going to be an inequality. I'm going to start with x. My smallest x value is that 0, and I'm going to the right. So x can be anything greater than or equal to 0. My range, again, y's, I'm going up. So my smallest y value is the 0, so y can also be anything greater than or equal to 0. Now, to draw the vertical line test, I can do a series of vertical lines. One time. one time. One time. Each vertical line only touches the graph once. This passes the vertical line test. This is a function. Okay, so now let's move on to the other graph, right? Notice that these two graphs are kind of similar, except this other graph has the bottom parts too, all right? So again, maybe that gives you a hint. So again, if I look at this point right here, right? This is the point 0, 0. Okay, so now in terms of my domain, notice these arrows. This one is going up into the right. That means up, sorry. Again, P. This arrow is going down into the right. So if we look at our domain for this graph, right? So x is still going to be here at 0, and it's going to the right. So x is still going to be greater than or equal to 0. But now if you look at the range, yes, this y value is 0, but notice that there are y values less than 0 down here. And there are also y values greater than 0 up here. Because this arrow goes up and this arrow goes down, y can be anything. So for the range of y, we say all real numbers. So just be aware of which way the arrows are pointing. Okay? And now if we do the vertical line test, here I go. Let me draw a vertical line. Uh-oh. 1, 2. This vertical line touches the graph more than once, which means that that x value has a y up here and a y down here, which is bad. This means it is not a function. That says function. Believe me. Perfect. Okay, so you should know everything there is to know about domain, range, discrete, continuous, and determining whether a relation is a function. All right, thanks for watching. Good luck on the practice.